So good morning, everyone. I'm Patrick Mechin, the CEO of TECHWAY. TECHWAY is a French company specialized in FPGA technology. I'm here today to talk about optical and optical communication, and especially optical communication in embedded systems. So as an FPGA technology, we've been exposed to high-speed communication almost 10 years ago when our customers came to us asking for implementation of high-speed sensors. And I remember coming to this conference almost 5 years ago with some drawing and sharing with you guys our thoughts on how optical communication was getting strong and how it could become a real trend in our industry. And I'm pleased to be here again today with real solution to present you. And also I was impressed by the number of speeches that have been given and will be given during this presentation, during this conference, about optical communication, which shows, if needed, that the trend is there and the trend is strong. So let's see what's happening on high-speed communication. And for sure, the trend is driven by technology, and one of the main technology driving high-speed communication is FPGAs. So if we have a look on today's technology on FPGAs, they are offering not only that they are going faster, but they are offering more and more high-speed communication links. You see today technology offers up to 30 and plus high-speed serial links and operating at 32 gigabit per sec. And if you think about it, it's almost twice the quantity of it's 3 times the quantity of link and twice the speed we had, 3-4 years ago. So really, this technology is driving the need here. FMC Plus, a standard, is also an important part of it because it's evolving. I mean, FMC technology Plus has been released last year, and it has been defined to cope with what today's FPGA can offer. If you look at what FMC is providing today in its new version, the main thing is giving more room for high-speed serial link than the previous generation. Rough number, we had 10 high-speed serial links available on FMC, and we now have up to 24 high-speed serial links available on FMC Plus. So thanks to this VITA technology, we really have means to implement high-density optical serial link into systems. Protocol are going faster. They want to enjoy the capability offered by the hardware, by the FPGAs, and all the protocol that we are dealing with out there, starting from 10 gig Ethernet to serial FPDP to GESD, want to take advantages of the capability of the FPGAs and are continuously under redefinition or under upgrade in order to take benefit of higher speed. And lastly, there are issues. A big driver is with data. Their need for high-density data is important today. This is driven by sensors. Just think about new sensors like a high-resolution camera or phase array antenna, not to mention only these two, that are providing huge quantity of data. This trend is also fueled by the need for ever higher bandwidth analysis that is required in the radar industry or in the electronic warfare industry, and in fact in all industry. People want to process more and more data. in order to do a finer analysis of their phenomena. So these are driving trends, and let's have a look on how people deal with that and what are the challenges here. So we see three communication needs into system that in fact have been mentioned also yesterday by some speakers. So not really new here, but it's good to recap what we can observe. There are for sure needs to connect sensors to the systems, and today sensors are delivering their data on high-speed serial link. And thanks to optical technology, you can really interface them into your system and even think of using long-distance cable. There are needs inside the computer into the box in order to move data around, and there are needs from box to box, which are required today by the high density that you need to process into system if you want to achieve the requirements of your customers. So if you summarize and the main requirements, it's really a summary. What you need is optical. What you need is high density. And what is required also is robustness. Here we're talking about embedded systems, and all the technology that is described on this picture needs to operate in embedded systems. So one of the challenges is to start looking at these requirements and see how we can offer a solution to customers and to system integrators. But before doing so, I just wanted to review very quickly what are the technical challenges associated with this technology. We see three major challenges, and you won't be surprised by what I'm displaying here, but interesting to recap. There are challenges concerning thermal. We all know the faster we go, the more power we create, and the more power we need to deal with, which means thermal, which means things we are all aware of. It's a challenge that needs to be considered. Second one is bitrate. I mean, the high-speed serial today goes really, really fast. I mean, we are doing 10 gigabit per sec is today a standard technology. FPGA can provide up to 32, as we have seen. Many systems today are implementing 25 gig per sec. This is sort of the state of the art for optical devices. And everyone is working currently on being able to deliver 32 and 56 gigabit per sec. So really things are going real fast. And it's easy on the paper, it's less easy on the hardware. The faster you go here, the more difficult it is to get your data getting through correctly. So here we're talking about signal integrity and data integrity, and there are issues to be solved here. Lastly, there are issues when we want to address the embedded computing industry about density or capacity. Optical modules that are available on the market, if we want to cope with the constraints and the requirements and the embedded solution, just think about conduction core system where you don't have a lot of room to implement your optical communication. You would need to find very low profile devices in order to build boards like the one I'm going to present later on, which are compact enough to fit into an embedded system. So thermal, signal integrity, capacity are the challenge we had, at least we had to deal with at TECHWAY in order to offer operational solution to our customers. So let's have a brief look on what we are offering these days to the industry. This is an outcome of almost 7 years of work. We picked up the FMC form factor to deliver optical solution to the marketplace. Why FMC? I shouldn't even ask the question. It's so obvious. Today, FPGA is the only technology that can deliver high-speed serial link, or it's the only technology you have available to implement high-speed serial linking system. It's also the technology that will allow you to implement the protocol, any type of protocol you want to deal with. So you need to connect to an FPGA in order to deal with high-speed serial link. And connect to an FPGA, it's the essence of the FMC form factor. So using FMC did really make sense for us to have access to FPGA. And starting from there, we created, we made a partnership with Radial that provide the devices which are rugged. I mean, Radial is specialized, as Laurence explained to us yesterday, in producing optical devices for rugged and harsh environmental. And it's the only technology we found out there in order to deliver our customers with conduction cool and extremely rugged type of FMCs. So that's how it looks like. It's a small FMC which features the Radial optical modules onto it and has been qualified to the highest level of robustness. We also created a product line with Samtech in order to deliver less robust for the industrial market and cheaper solution, of course, for people who didn't need it to have conduction cool solution, but were facing the same constraint of using optical connectivity in their system in order to achieve state-of-the-art equipment. So there is a market in defense, but there is also opportunity in the industrial sector. And of course, this type of market, they are not willing to pay the high dollars of the defense embedded system. And that's why we picked up that solution. And lastly, we did something, oops, disappeared. We did something, we created a rear I/O type of connectivity on our FMC. You will see some more picture later on. That will allow customers in the defense sector to take benefit of the back-end connectivity defined by VITA 66 that will allow system integrator to implement into the box optical communication. So to summarize, our solutions are fully compliant with VITA technology. We use FMC+. We connect to VITA 66 using our rear I/O capabilities. And our boards are qualified up to the VITA 47 environmental specification. So we have air cool, we have conduction cool. I won't go into the details. It speaks by itself. One thing to notice here, if you look at the conduction cool board, you will see this very new or innovative, unique type of connectors that have been provided to us by Radial. They are specifically designed, they are metal-based, and they are specifically designed for rugged optical connectivity. Let's go quick on some advanced features you will find with our boards. I'm sort of proud to present our flagship. This is really something unique. There is no equivalent. We did it for a customer, a French system integrator. On this rugged FMC, you have up to 24 lines going in 24 lines out, each of them operating at 12 gig. So I'll let you compute the bandwidth of the board. It's amazing. So it shows, the density that we are offering with these small FMCs. And it's pretty neat. And you can imagine the signal integrity issue we needed to sort it, as well as the power dissipation issue on such a board. Go quick, because I see Jerry is standing up. We did something special on our board. Just quick look. It looks a little bit techy, but it's interesting. We are fully compliant with the VITA specification that says that each group of 4 high-speed serial links needs to have its own clock. So we have implemented that on the board. I don't know how the engineer found room to do that, but we did. And from a customer standpoint of view, it gives the ability on a single board to operate multiple protocols concurrently. So you have a board like that in your system, and you can take data using serial FPDP protocol and send it back to another computer using 10 gig Ethernet protocol, same board. Okay, and of course it's rugged. Okay, and oops, we have a rare I/O option. That's the roadmap from TECHWAY. Very simple. We have 4x4, 12x12. You have the flagship with the 24. And everything operates at 12 gig per sec. It's rugged, it's qualified, it operates on the field. Okay? And we're working currently with Radial to offer the 28 gigabit version. It's work in progress. We think we're going to be ready in a year and a half from now to offer a fully qualified solution. This is it. Our CTO, Mr. Eric Mazuir, is in the room. If you have deep technical questions, we also have sample of our flagship board if you're curious to have a look at it. Thank you very much.